Hello and welcome to Mathematical Coaching Center. Today in this video we'll see a theorem related to circle. But before we start, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further delay, let's begin. So let us first see the statement of the theorem. The statement of the theorem says that the perpendicular drawn to a chord which is not a diameter from the center of the circle will bisect the chord. Okay, bisects the chord. So the statement says that if we draw a perpendicular to a chord from the center of the circle, that will bisect the chord. So let us understand what the chord center, okay, diameter and all. So if this is a circle, this is the center of the circle. Okay, now if we draw a line from the center of the circle to the point on the circle, okay, this line segment here, from the center to the circumference of the circle. So this kind of line segment is known as radius. This is the radius of a circle. Next, if we draw a line which joins 2 points on the circumference of a circle, this is a line that is joining 2 points on the circumference of a circle. This kind of line segment is known as chord. Okay, it can be anywhere, so you can draw it here also. This is also a chord. It joins 2 points on the circumference of a circle. Now if we draw the same line joining 2 points, but it is passing through the center of a circle. Now this is a line segment that is joining 2 points. Okay, it is joining 2 points and it is passing through the center of a circle. So this kind of line segment is known as diameter. Okay, so diameter is a special case of a chord. Now let us begin with the theorem. So let us see the diagram. So the perpendicular drawn from the chord, so this is the perpendicular drawn from the center of the circle, that O is the center of the circle, OD is the perpendicular, and AB is the chord. And AB does not pass through the center of the circle, that is O, that means it is not a diameter. So in given, what we'll write as AB is the chord of a circle with the center at O. See, AB is the chord of a circle with the center at O, and which is not a diameter. This is not a diameter. This AB is just a chord which is not diameter. And OD, and what is OD? This line segment OD is perpendicular on the chord AB. So this is perpendicular on the chord AB. So this is 90 degree here. And what is O? O is the center of the circle. So this is the things that you must write in given. So we are given with the center to be O, AB is the chord, and OD is the perpendicular. And what does the statement says? It says that it bisects the chord. Now this OD bisects AB into two halves. Okay, so that is what we need to write in required to prove that OD bisects the chord AB. That OD, this line OD will bisect the line AB into two halves. That means the segment AD, the line segment AD, A from D till here, and from D to B, this two length must be equal. So AD should be equal to BD. So we need to prove that AD is equals to BD. So to prove that, we need to make a construction. So let's see the construction. So what we will do is we will join OA, O and A will join this 2 point, and we'll join O and B. Okay, so O and B. So after joining, this is what we'll get, joining O and A, and this is what we'll get, joining O and B. So now here I see that there is a two triangles out here. So this one is OAD, this is one of the triangle here, and ODB, this is the other triangle here. So in proof, we'll take the help of these two triangles. Now OD is perpendicular on the chord AB. So OD is perpendicular, it is already given. That means this is 90 degree, and this side also it will become a 90 degree, because the total sum of a straight line should be 180 degree. So this is 90 degree on both the sides. Now that means triangle ODA. ODA. So this triangle here is a right angle triangle, and ODB is also a right angle triangle. Both this triangle are right angle triangle because it has one angle as 90 degree. Okay, now we'll take the help of these two triangles ODA and ODB, and we know that these two triangles are right angled triangle. Number one, what we can see is that ODA is equals to ODB. ODA, that is this angle here, is equals to ODB. Why are these two angles equal? Because they are both 90 degree. So this angle is also 90 degree here, this angle is also 90 degree here, so they are equal. So what is the reason? Both right angle. Next, the hypotenuse OA. So this is a right angle triangle and this OA is the hypotenuse, and OB is also the hypotenuse here. So these two are equal. Okay, can we say that these two are equal? And why? What is the reason that these two line segments are equal? It is because they are the radii of the same circle. OA is also the radius of the circle. Okay, this circle OA is the radius and OB is also the radius. So since they are the radius of the same circle, that means they have to be equal. So hypotenuse OA is equals to hypotenuse OB. And finally, what we can see is that OD is common. So this line segment OD is present on both the triangles. So OD will be equal to OD because they are the same side. So side OD is common. Therefore, what we can say is that the triangle ODA, that means this triangle here, and ODB, this triangle here, are congruent. And what do we mean by congruent? They are exactly same. They are exactly same, and this is by the side angle side axiom. So now, if they are exactly same, what we can say is that the side AD, that means this side AD, will be equal to side DB. And why are they these two sides equal? Because they are corresponding sides. So this is how we prove this theorem. Now let's take an example to understand what exactly this theorem is trying to say. So if OD is perpendicular to AB and O is the center of the circle, and AB is given as this line segment from A to B is given as 10 centimeter, then find the value of AD and BD. Okay, we need to find what is AD and BD. So now we know that AD is equals to BD, because if this OD is perpendicular to AB and this line segment is drawn from the center of the circle, that means it will bisect the chord. That means AD will be equal to BD. Now let's say this to be X. So this is X and this also X. The length I am taking it to be X. Now we know that from A to D and D to B, if we add from A to D and from D to B, if we add these two lines, we'll get the whole line, that is AB. And what is AD? AD is X and BD is also X. And what is AB? It is 10 centimeter. So X plus X is 2X, and cancelling this, 2 5s are 10. So we'll get X to be 5 centimeter. So what is the length of AD? It is 5. And what is the length of BD? It is also 5. So the total becomes 10 centimeter. So this is centimeter. Okay, I hope that this video is helpful for you in understanding the proof of the theorem. So in the next video, what we will do is we will try to solve few application of this theorem. Okay, thank you for watching and have a good day.